Okay? It says the slope of a line, m, that's your symbol for slope, okay, is rise over run. And then it's got some other stuff. It's got this funny triangle y. What does that mean? Is that like a Greek letter there? It's called delta. It means the change in. What's the change in y? What's the change in that point and that point? Would that be like 6? Is that the same thing as saying rise? Yeah, it is, right? What's the change in those 2 points? Vertically, that's y. What's the change in a couple of run points? If this is a 1 and that's a 3, what's the change? The change is 2. The difference between 3 and run, 1. Change in x says the same thing. Okay, what we're going to do today is the other stuff it has there. y2 minus y1 over x2 minus x1. That's the slope formula. So a little bit of review. Slope is the measure of, if you got one word, and I'm talking about a line, what's the word? Starts with an S, right? Yell it out. Anybody? Not smog. What's the new Hobbit movie? Steepness, right? Steeper, even steeper. Hey, now we're getting fun when we go skiing. That's instant death, okay? Right? Anything from horizontal, what's the slope of a horizontal line? 0, right? Because our definition is rise over run. How much does this rise from here to here? It does not. Might as well do it since I'm talking about it. A horizontal line segment, if slope is rise over run and it doesn't rise, I don't care what the run is. Put any number you like. Put that in your calculator, and it has 0. All right? Vertical line, rise over run. I got a rise. Let's say the rise is 11. What's the run? How far does this thing go horizontally? It doesn't. How many times does 0 go in 11? We don't know. So we say undefined. I can't define how many times 0 goes in 11. Okay? Memorize that. Easy marks. Slope is steepness. A vertical line is very, very steep. Okay? The only way you could get up it is to plug things in the rock and tie yourself on and pull yourself up, right? Okay? You can't ski this. It's just called falling. Slope is the ratio of the vertical change over the horizontal change, rise over run. A line segment which rises from left to right has a, is that positive or negative? Okay? I don't expect you to memorize these words, but when you look at the line, you got to know if it's positive or negative. Okay? 99.9% of us, just visual, look at the picture, that's positive. Okay? Look at that picture, that's negative. The definition, if it falls from left to right, that line's falling, then it's a negative slope. Okay? The slopes of all line segments on a line. What can I say about the slope of AB versus the slope of BC? They are the same. Yeah. Okay? All right. Developing the slope formula. Calculate the slope of this line segment. Again, if the points are right on the ends and it's kind of nice, you can use them. But if they're not, then you got to use a point you're sure you know the coordinates of. Let's use this one. Okay, what's the slope? What's the rise here? 1. What's the run? 2. And then you have to look and go, is that a positive or a negative slope? That's positive. Okay, it tilts to the right as the line goes up. So that's the slope, 1/2. If I would have used these points, I would have got the same thing. 3 over 1, 2, 3, 4, 5, 6. 3 over 6, that's also a half, isn't it? Okay? What's the coordinates of the endpoints of AB? A is, now this is weird, I just got the first quadrant here, right? So this is, where is A? There's 1 and 5, 6, 7, 8. Point B, how do I get over there? I go 5, 6, that's 7, and then I climb up 5, 10, 7, 11. Okay? Those are the coordinates of those points. Knowing what rise is, how can we determine the line segment using the points of YB, that's 11, and YA, that's 8? How can we do that? Let's write that the way I also said it there, 3 over 6. Well, what's the difference between 11 and 8? If we count from 8 to 11, we get 3, don't we? What's 11 take away 8? How can the rise be determined? If I go coordinate B, that's 11, minus coordinate A, that's 8, I get 3. That's the rise of this line. How can the run be determined by the coordinates if between XA and XB? Okay, well again, that was 7. This was 1. Is the difference of those 2 points 6? Yep. If I go XB minus XA, 7 minus 1, I get 6. And that's the run. So use your results from what we just did here and here to write a formula which describes how the slope of the line can be used by calculating its endpoints. So slope, that's M, is rise over run, but rise was YB minus YA, run was XB minus XA. Well, there's our formula. That's it. So that was a little investigation, okay? The more we understand about what this thing is, that kind of should be like common sense. But if it isn't, well, it's on your formula sheet. Okay, you can look it up. There it is. The difference of the y points, otherwise called as the rise, over the difference of the x points, okay, or called the run. That's what slope is. Okay, and again, I said it about 6 times, but now it actually says it. The letter M is used to represent slope. Okay, don't ask me why. I guess M in Greek means line, steepness, okay, sweating, I don't know. Okay, I didn't come up with it. That's what we got to use. All right, so this is how it is. It's y2 minus y1. There's no a, b's, and c's here. You just got to take the 2 points and determine what the slope is. Okay, so notice there's no picture anymore. I mean, you could draw it. You could plot these 2 points, but we shouldn't. Okay? We should just use our formula. I'm not going to use this funny thing. I'm going to go right to that. Slope is y2 minus y1 over x2 minus x1. Because every time we give you a couple of points, it's going to be a different letter. Okay? It doesn't matter what the letters are. There's 2 points. We want to find the slope of that line. For the first few, I strongly recommend you do this. This is always coordinates x and y, right? So let's label that x1, y1. So that's going to be x2, y2. If that's all you do, the rest is easy. All you got to do is plug it in where you see this in the formula. Okay? y2, well, here it is. That's minus 2. Minus y1, here it is. That's 8. Over x2, here it is. That's 7. Minus x1, that's minus 3. Okay? Well, what's minus 2 minus 8? Minus 10. 7 minus minus 3, that's like 7 plus 3, right? That's positive 10. And what's negative 10 divided by positive 10? Negative 1. Okay, that's still a slope. If you want to see the rise and the run, if you got to graph this thing, that's what you do. It's 1 unit of rise, 1 unit of run. Okay? From wherever, I don't know where this is exactly, the line, but that's definitely the slope. Okay? So, what happens, because I always get this question, if they gave that point first and that point second, should the slope change? No, it's the same 2 points. Wherever this is, it's the same line. It's got to be the same slope. What happens if you mix up these 2 points? Well, let's say this one now was the first point, right? x1, y1, that's x2, y2. I'm going to use the same formula. I'm going to go y2, 8, minus y1, minus 2, over x2, that's minus 3, minus, what's x1? 7. 8 plus 2 is 10. Minus 7, minus 3, sorry, minus 3 minus 7 is minus 10. Do I get the same thing? Yes. Okay? So it doesn't matter which 2 points you use first or second. Just, like I said, this is a good idea because you always get some kid wanting to take this point minus that one, okay, and then this point minus that one, screwing it up. Okay? Just don't make that mistake. I recommend you do this. Okay, this is usually more confusing than it's helpful. Collinear. I don't know if they'll ask you what this is. Okay, I don't on my test, but it's still a good little exercise. We already looked at this. What can you say if this is a line between the slopes of PQ and QR? Yeah, so the slope of PQ equals the slope of QR. If that happens, then all these points are collinear. They're on the same line. That's what it's saying. So they got a little exercise. Prove, consider these points. There's 1 point, there's 2 points, there's 3 points. Prove that those points are collinear. So a quick little sketch tells me, okay, minus 7 and 33, that's up here somewhere. 2, 6, that's like here somewhere. And 5 minus 3, that's like here somewhere. Okay? How do I know that these guys are collinear? Well, what did I just say? They're collinear if this slope equals that slope, right? Then you can say they're all line segments on the same line. So all we got to do to prove this is say, well, the slope of AB, if that equals the slope of BC, then it's proved. Okay? They're all on the same line. Because if they're on the same line, the slope can't change, right? This slope can't be like this, and this one be like this. Then by definition, they're not collinear. Okay? So slope formula, again, you can refer to your formula sheet, but it usually doesn't take kids too long to memorize that. Okay? Slope of AB, I'm going to do, so let's label these points. That's going to be right underneath. x1, y1, x2, y2, and all you have to do is just plug them in. It's just like Lego, right? Put the blue block here, put the yellow one there. Okay, so y2, 6, minus, what's y1? Minus 3. x2 is 2, minus, what's x1? 5. So 6 plus 3 is 9. 2 minus 5 is minus 3. Does 3 go into 9? Like 3 times? Yes. So this is negative 3. Let's find the slope of BC. So again, I've already labeled this x2, y2. So how about I label that x1, not x, y1. Now I want the slope of these two. Okay, so y2 is 6 minus, what's y1? 33 over x2 minus x1, x2 minus x1. What's 33 take away from 6? 27 negative, right? And 2 plus 7 is 9. Is that the same slope? Aha. Proved. Or if you get to university, QED. Again, it's some Latin or Greek or something like that. I don't know. That means proved. Okay? So if these have the same slope as these two, then they're all on the same line. They're collinear. Okay? B, find the value of y right here if this point lies on line segment AC. So this is part B. This is the same question. Well, I don't know where this point is. Point D, minus 4y. Let's say it's there. What do I know? If it's on the line, do we know something about the slope? Yeah, it's got to be the same, right? If it lies on segment AC, I know the slope is minus 3. Okay? I know another point on this line, like A. So to find out y, use your slope formula, plug everything in, solve it for y. Okay? I know the slope is minus 3. Okay? Let's call this x1, y1, x2, y2. So this is y2 minus y1. y2 is y, don't know what it is, minus y1 is minus 3 over x2 minus x1. There's one equation, only have one variable, so I should be able to solve for it. Okay, first let's clean it up a bit. Y minus minus 3 is y plus 3. Minus 4 minus 5, what's that? That's minus 9. Now, the grade 8 part, the tricky part, the algebra. How do I solve that thing for y? Yeah, get y by itself. I want y equals everything else, right? I got to get rid of this 3. Get rid of the minus 9. I could multiply both sides by negative 9. There's another way to explain that. Remember cross product, cross multiply? Okay, if some people use it, fine. That's like negative 3 over 1. Cross multiplying means multiply this times this, negative 3 times minus 9. And that equals 1 times y plus 3. So is that the same thing as multiplying both sides by negative 9? It is. So let me just backtrack. If you like cross multiplying, that's what you got. Big kid way would be, I want to get rid of negative 9. I'm going to multiply both sides by negative 9. That cancels out. Do I get the same thing? Yes. All right? Because we don't like fractions. We want to get rid of the fraction. That's why we do this. So negative 3 times negative 9 is positive 27 is y plus 3. All I got to do is get rid of the 3 and I'm done. How do I get rid of plus 3? Doing the opposite operation. The opposite of plus is minus to both sides. So y is 24. Okay? So that one's a little funner. Do we want to see another one like that? Calvin doesn't. Anybody? You're good? All right. Because I could give you another one. You will get a couple like that on our little test on Thursday.